Electron Configuration Practice Worksheet Part 2. The last video I explained how to do the unabbreviated electron configuration. Now I'm going to show you how to do an abbreviated electron configuration. I'm sure you noticed when you were looking at these that writing out the electron configurations when you get to the ones that are down here can get very long very fast. And we don't want to have to write all that for all of these different elements. So there is an abbreviated method to doing these problems. And let me pull that out real quick. It's in your reading material, and it does say on it, abbreviated electron configuration. So let me show you the example we have here. This shows us cobalt, which we did on the other page. Cobalt, doing 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7, which got us to 3d7 here at cobalt. Now, rather than have to write all that out, I would rather do this in a way that is shorter, a way that's abbreviated. And let me show you what we do with that. Rather than write all of this, notice that no matter which electron configuration I'm doing, they're always going to go in this order. First 1s, then 2s, 2p, 3s, 3p, and so on. So I'm going to look at the noble gases here. The noble gases are the most stable atoms of all of our elements. So what I'm going to do then is compare whatever element I'm looking at to one of the noble gases. And here's how I do that. Notice the closest, excuse me, let me move this back down so we can see all of it. The closest noble gas to cobalt, if we go backward, all right, here's cobalt, I'm going to go backward. Here's element 19, 18, argon is the closest noble gas. Here's the electron configuration for argon. Now what I'm going to do is on this next part, it shows both of those next to each other. It shows cobalt and argon one over the other. So notice we have cobalt was right here, and it's just rewritten again, and then argon is here, and I've shown it right here. Notice they both have 1s2, 2s2, 2p6, 3s2, and 3p6 is all the same. The only difference is that cobalt kept going after 3p6 and added 4s2 from right here and 3d7 all the way over to here. So this is added on to the end of argon to get to cobalt. So what we can do is we can write a method that shows, hey, cobalt is just like argon, but with 4s2 and 3d7 at the end. So what you do, you put the symbol of the noble gas before it, for example argon, in brackets, and then put what it didn't have in common at the end. All right, another example is down here. Here is the abbreviated electron configuration for strontium, which would be krypton plus 5s2. Because if we look at krypton right here, all right, krypton is element 36. Oh, excuse me. Yeah, there we go. Element 36 is krypton. Krypton comes before strontium, which is element 38. So it's the closest noble gas before it, 37, 36. Gets me here. All right, so I say it's just like krypton plus 5s2. And that way I don't have to write out all of this. It makes it a lot shorter. So let's do another example. Let me do the example of osmium. It's OS. Let me get this where we can see it all. And I'm going to put this here. Osmium is element 76, OS. Now notice, this would be really long. I'd have to put all of those different symbols in there all the way until I got to 76 electrons. Now I don't want to have to do all that. So I'm going to go from 76 backwards, 75, 74, right, all the way back over here to 55. Oh, excuse me. I'm sorry. I don't want to use osmium as an example because of this jump right here. Let's use molybdenum, MO. So I'm going to use MO as my example, molybdenum. That's 42 electrons. So I'm going to go backward, 41, 40, 39, etc., until I get to krypton here. All right, so krypton is the element, the noble gas, I should say, before it. All right, the closest one before it. So I went back to krypton, and then from 36 I'd go back here to 37, which means I start with 5s2 because there's 2 here, and then 4d, 1, 2, 3, 4. All right, that's all we have to do. Find the element you're looking for, go backward till you find the noble gas before it, put that noble gas in brackets, then go to the next sublevel and put those sublevels until you get to the one that you're going to. So that is how you'll do questions 6 through 10. Now for 11 through 15, all you have to do is figure out which element these are. So don't forget, they always fill up the same way until we get to the last one. So think about which part you need to look at. So that's what you'll do for these, just tell which element that would be. And then on 16 through 20, you have to tell if it's valid or not valid. In other words, is this an order that they could actually fill up in? So you'll look back at this chart and make sure that 1s2, 2s2, right, etc., fills up in the correct order. If it doesn't, you'll put not valid. If it can happen like this, and it's a correct way of writing it, you'll put valid. If you still have any questions, again, please feel free to ask.